This is the last of the final review for the final exam. I'll be putting this in tomorrow morning. Describe the sequence of transformations from the related common function. Notice that we're going from x cubed to all of this. So let's start at here. So first we reflect over the x. That's the negative. The 4 is a vertical stretch of 4. The plus 4 on the inside means that we're shifting to the left 4. And the minus 2 on the outside means we're shifting down 2. Alright, 42. Find the inverse function. So step 1, place the f of x with y. Y equals x squared minus 3. Step 2, x and y trade places. So x is equal to y squared minus 3. And now isolate the y. So we're going to add 3 to both sides. So x plus 3 is equal to y squared. Then we're going to take the roots. So y equals the square root of x plus 3. If you want to make it fancy, alright, 43. What is the correct equation and domain of the graph shown below? So we know that the domain is x is greater than or equal to 0. And if you draw the rest of this, you can see that this is a parabola. So y equals, now it's opening down, so it's negative. It's shifted down, so it's minus 1. And it is 1 to 1, so it's x squared. No shift left, right. Just negative because of the reflection, and minus 1 because it moved down 1. 44. Which polynomial has a point of inflection at negative 1 and a multiplicity of 2? So negative 1 would look like this in the parentheses, and a multiplicity of 2 would have a 2 right here. So you're looking for an x plus 1 squared, which means C is your answer. 45. Graph the function shown below. And they want us to show that x is an absolute value. So if we transformed it, we want only positive x's. So what would happen is everything over here on this left side would bounce and it would come back. Notice that this is already a reflection here. These two already match. So on my new graph, you'd already have from the negative 4 on, right? We'd already have this part, but then we have this other part that bounces down, so it would bounce down like that. Now this is not a perfect match. That should be a negative 2. Oh, sorry, this should be a positive 2, and this should be a positive 4. This should go down negative 4, and this should go up positive 2. And so everything would be on this side only, nothing on the left. 46. Are these two inverse functions? If they are, then f of g of x is equal to x. So let's see. When half times 2x minus 1 plus 1 has got to be equal to x. So half of 2 is x. Half of negative 1 is negative 1 half. And if we add that to 1, that's going to be x plus a half. And the answer is no. Not inverse. It has to equal x. Alright, number 47. What is the remainder of the division? So, we have 1, negative 3, negative 2, negative 19. If this is a minus 3, we're divided by a positive 3. This right here means divide by positive 3. Drop the 1. 3 times 1 is 3. That goes to 0. 3 times 0 is 0. That goes to negative 2, and 3 times negative 2 is negative 6. So it's negative 25. That's your remainder. Alright, we're almost done. 48. What happens to the value as it approaches negative infinity? Okay, here is your graph. Now, an x cubed usually looks like this. But if it's negative, it's going to flip this way. So as we approach negative infinity, what does our f of x do? It goes up, up, up. It goes to positive infinity. 49, which one of these is a quartic polynomial? Quartic means x to the fourth. Notice here's 1x, here's 2, so that's an x cubed. That's not right. Here's 1x, here's 2 plus 1. There's 4. This could be it. 1x and 2, that's x cubed. That's not right. And 1 and 1 gives me x squared. Not right. B is the answer. Last one. You have 2x squared plus 3, and they want to find x minus 2. So we're plugging that in here. So you got to do the box method. X minus 2, x minus 2. X times x is x squared, minus 2x, positive 4. So right here, you'd have x squared minus 4x plus 4. But there's a 2 in front, and there's a plus 3 on the end. So 2 times x squared is 2x squared, 2 times negative 4 is negative 8x, and 2 times positive 4 is positive 8. Don't forget you have plus 3 there, so 2x squared minus 8x plus 11.